In this video clip, we will talk about the definition of set. What's the meaning for a set? A set right here is a collection of objects interested. That means if we are interested in a group of sets, we can put them together and the collection of those objects will then form a set. So the definition of set looks very primitive. And then each object in the set is then called an element of the set. So object in a set is basically called the element. And here we have an example right here. Is a collection of computers produced by Apple company. This phrase will give a definition of a set, and this definition is well given. Is because for any computer, it is either produced by Apple company or it is not. Okay, so if it is produced by the Apple company, then it will be in the set. Otherwise, the computer will not be in the set. Sometimes we try to give a definition of a set, and if we are not careful enough, then the phrase may not even give the definition of a set. You see the example right here is a collection of the best computers. And here the problem is the standard for the best is not clear. If you have a good standard for the best, then this definition maybe will give a definition of a set. But here the problem is that the best is not well defined. Okay, you may say some computers are the best computers, but for the same computer, other people may think that's not the good computer. So in this case, a computer belongs to this set or not is not clear. So in this case, then we say this phrase does not give a definition for a set. All right, so when we are defining a set, this definition needs to be well defined. Okay, that's very important thing. And that's basically in this paragraph, this sentence is important. Is we want to emphasize a set needs to be well defined. Now is that how we are going to represent a set. Sets are normally denoted by uppercase English letters such as A, B, C, D, E, F, G. Okay, so we use uppercase letters. And for the elements in a set, we normally use lowercase English letters, okay, such as ABC and so on. Let's say U, in this case, denote a set, which is a set of no negative integers less than 10. This phrase give a very good definition for a set, because it is clear that 1 is inside, and then -1 will not be inside the set U. So if an element is inside a set, how we are going to represent it is right here. If 1 is inside U, you may denote in this way. 1 is inside U. And if an element is not inside set U, you may denote in this way. You may denote in this way is -1 is not in set U. And you can see right here, this one means not in a set. All right. So this paragraph is basically about how to represent a set and its element, and if a set is inside a set U, how we are going to represent it. That's for this paragraph. Now, let's look at how we are going to describe a set. How we are going to describe a set. That's basically right here. You see, we can describe U in this way. And in this case, we say this description is a Rust notation. It means every element inside U is listed here. It's very clear. This notation normally works for the finite elements in a set. So if there are only finite elements in a set, then we say the set is a finite set. The set is a finite set. Okay. Let me mark the finite set here. So there are only finite elements. In this case, we have how many elements? From 0 to 9. So we have 10 elements inside. There are cases is that sometimes there are infinitely many elements. Infinitely many elements in a set. Then in this case, such a set will be called infinite set. If a set is like that, using the Rust notation may not work. Okay, so we have to use set builder notation. Okay, and here is the example for the set builder notation. X X stands for the element in the set U. And after this vertical line, then we got the description about this element, typical element or representative element in the set U. It tells us that X has to be an integer and it has to be in a range from 0, greater than 0, but less than 10 means at most 9. Okay, so in this case, U can be described in two ways. The second way is set builder notation. This is for finite set with the set builder notation. There are cases like this. Here is that X again is a representative element. Okay, and the R stands for the real number set. So this basically tells us that X is a real number and X has this description, this property. X is less than 0. Okay, so then how many elements in B? Then it will be less than 0, then it can be -5 or -0.5, -1, -2, -3, -5, -6, keep going. So in this case, B is an infinite set, and it's impossible to use the raster notation to describe this set B. So in this case, the set builder notation has to be used. Okay, now we said here R is a real number set. Mathematically, there are typical sets. We use typical letters. And here are some examples right here. You see here, N stands for the set of natural numbers. I guess here is because natural numbers, this the vocabulary starting with N. So we bold this first letter like capital N. That's natural numbers. Natural number starts with 0, 1, 2, 3. Many things going on after that. And here, N star or N plus, 1 is on the top right, plus is on the right bottom. That's positive integers. Means this letter, 0 is out. Okay, that's the only difference between N and N star. Z normally stands for the set of integers. It means -3, -2, -1, 0, keep going, all are included. Okay, so Z is actually bigger than N. Now, how about Q? Q stands for rational numbers. It means can be a what? A fractional number. So you see, can be 1 over 2, can be negative 2 over 3. Of course, it can be what? It can be 5 over 1. 5 over 1 is just what? 5. So Q is bigger than Z, N star. Okay, that's rational numbers. R then, of course, is bigger than Q. So all real numbers. That means R includes what? Irrational numbers, like radical 2, okay, like pi, like what? You'll see this number on your calculator. E stands for Euler constant. Euler constant, which is like 2 point something. Okay. All right. I'll see you next time.